right now?
Yeah, so we are doing a quick rebuild right now on the cloud. As it's going, today is going to be covering events, but we had some funky situations where like our it's working locally, but it's not working in the cloud, so we're just trying to fix that. People are Parzel's working on that now. All right, welcome everybody to week 2 of the Magick Academy. We've been building really hard. A lot of things have happened. A few interesting developments out in the world as well. Some things that were somewhat foreign concepts to a lot of people, like AGI or agents and agentic frameworks and things, are suddenly becoming very popular and on trend. And that kind of helps us, I think, to sort of tell our story. And for a long time we were trying to explain things to people that I think were 2 or 3 steps ahead of where the meta was, and now I think we're right there. So I want to show you guys a couple of, let's actually talk about what's going on in the world first, and then we'll get into a little bit of review of last week, just kind of making sure everybody's caught up, and then we're going to talk about the next stuff, which is going to be the cognitive loop, and making our agents actually somewhat intelligent and having more than just a call and response of goldfish memory. And so we're going to be focusing on events, short-term memory, long-term memory, as well as vectors and embeddings. We're going to talk about all that stuff and what it means. But first, I want to show you guys some stuff. So there's this idea now of autonomous agents. And we've been talking about this for years, but we didn't really have the tech to make it super possible until very recently. And Parzel and I, when we started this project, this was our dream. Autonomous agents that can walk around the world in 3D or 2D or whatever, and you can interact with them, you can give them tasks, they can execute those tasks and return information, whenever they feel necessary. Not ChatGPT, not I ask a question and I get an answer, but I give a directive and I get an action or a series of actions. Or it creates its own directives and it just leads itself. Of course, you can imagine that can go into some kind of interesting places. So I want to show you guys a couple of projects that are on GitHub today that are open source. You can try them. They are all code. It's very complicated, and probably, if you're here working on Magick, this is probably a little bit scary to you, but it's good to know where it's going. And also, these are the kinds of things that we're also building on Magick, and we're going to be building toward, I think. One of them that's really interesting is Baby AGI, which does what it says. So AGI, artificial general intelligence. The really key part there is the general. It can do a lot of things. It can do anything. It can create and execute tasks, and those tasks are open-ended. They're not strict, do this and that, then that. It's kind of, well, what do I want to do? And then creating a sort of a list of, to-dos and then executing them one by one, or changing it as context changes. So Baby AGI is one of the first projects to come. And it's very compelling that you can just run this at home, plug in your OpenAI key, and you can give it a directive, tell it what you want it to do, and it will start doing it. There's some good examples of videos of people talking about this. And there's also a good web UI, not for this one, but for the other one I'm going to show you, which is AutoGPT. AutoGPT is another very similar project to Baby AGI. And I mean, you can even see it running. And it just sits and it runs and it creates thoughts, it executes them, it does the next thing. Very imperfect. Oftentimes it gets stuck in a hole, it just starts repeating itself, doesn't do much. But once in a while, it does something very, very cool. And I think, oh wow, this we could go really far with this thing. So I highly recommend checking out these projects. There's one other really interesting one that was made out of AutoGPT, which is called Chaos GPT. The AI bot that destroys humanity. Basically, someone took AutoGPT and thought, well, what if we just gave it directives to destroy everything? It's not very good at it. But it's a really interesting idea that maybe, look, this technology is really scary, but it doesn't have to be. And it's only scary because it's unknown, and we're not really sure of the outcomes. If we were sure of the outcomes, we wouldn't be scared of it at all. So before we have super crazy nuclear powered AI that could do something terrible if you told it to destroy humanity, we have this really bad toy version of it that's trying to destroy humanity, which actually gives us a lot of insight into how an AI might try. And from that, we can start to kind of red team our own systems. So I think that everything that's happening here is definitely going to be the future. This agentic model and agentic systems is definitely where this stuff is going. You're going to see 4chan trolls making evil versions. You're going to see people making good versions. But the net result of this, I think, is what's going to happen is look, we're all here to do good. And I think the better agents are going to win. And really, even if the evil agents are there, they're just not that like advanced yet. And we can, it's kind of like red team. It's like, it's like red teaming, or a good example is crypto. In crypto, first, what is red teaming? Red teaming is when you hire someone to try and break your stuff. And that's in hacking, there is red team and blue team. You can even look it up, red team versus blue team. And there's even a purple team, which is like a mix. But basically, if you look at any kind of info security, you have blue team. Blue team goes and makes sure that your technology is hardened and secure. Red team goes and makes sure, sees if they can break it. And what we're seeing right now in AGI development is a lot of this red teaming. But if you look at crypto, a lot of hacks, a lot of lost money. But it was relatively small scale. You could imagine if there were no hacks, and then we're like, well, crypto's great, let's adopt it for our entire global economy. And then there was one horrible hack, well, it would probably collapse everything. But instead, what's happened is lots and lots of small hacks, which have caused a increase in security mindset, and a lot more robustness for the entire system. So we'll talk a little bit about, I'm going to touch on a couple of the different themes of ethics and existential risk before we get into actually building. But I this is an important part of our belief, which is, look, bad things will happen. But if they happen early and they happen often, and we address them and we are vigilant, then we can actually make sure that this entire direction of AI stuff goes good, goes toward the direction of good, and it's robust. And if somebody tried to release a bad AGI, it would just be immediately stopped, flagged, kicked off, or, actively countered. So like that's, generally I'm very optimistic about the direction that all of our technology is going, even with things like chaos GPT in the world, because I think that what this is going to lead to is a very robust understanding of how these systems work, which we honestly just don't have yet. We're just figuring it out, So we're building toward AGI, right? And we're at the point now where this is realistic enough that it's not some far off dream. We can really do this. We're playing with fire. And, playing with fire is something we usually say is a bad idea, but pretty much every technological innovation has come from fire. And most of those technological innovations have been processes that took a long time to refine and were extremely dangerous at the beginning. And now people are very careful with and have down to a science. Everything from like a nuclear reactor, well, we've only had a couple of explosions ever, like they're surprisingly safe because there was so much effort and desire to make them safe. And so, yeah, we're playing with fire, but fire is very useful. And but you have to be respectful of the fire. You have to treat it with care. You have to be careful. You have to recognize that we are in an unknown Wild West territory. And it's really up to us to make this whole thing go well. If people are existentially afraid of what could happen with AI, I really think that it's going to be conscious people like us making things that are not, that are good, that you're not afraid of, that's going to change that and sort of bend the arc of time toward something that's really valuable for us and that we don't need to be afraid of. So let's talk about we don't have a terms of service yet for the Magick Cloud, but we're writing it right now. As alpha users, you sort of all are people we trust and know, and I don't think any of you are going to do insane things with it yet. But if you have any insane ideas, definitely ask us. But we do have some just like basic ground rules for what we want you to be doing or not doing with Magick, which I think are pretty reasonable. Basically, anything that's okay for a human to do is probably okay for an agent. Browse the internet. However, lying is probably not okay. Telling people that you're an AI, not an AI when you are, that could really hurt someone's trust in like their reality, like for real. And we want people to, obviously we want a lot of these things to be fun and game-like and realistic and engaging, but we don't want to lie to people. We don't want to spread disinformation. we could really easily use this technology to go and spam everybody, but it's not going to make the world better. It's not going to make the internet better. It's just not what we're doing here. If you want to do those kinds of things, we can talk about it and sort of figure out those, what the line is. But generally, no spamming, no lying, no stealing information, no disinformation, no hacking people. If you want to hack your own computer, that's fine. But just do unto others. We also don't torture your models, don't torture your AI. Obviously, if you that's probably one way to get into that sort of dystopia the fastest, is to treat them really badly. We don't really fully understand what we're up against yet. We don't fully understand the nature of intelligence. We should probably just default to kindness. And also, there's sort of a funny thing where if you ask an AI model kindly and with a please and thank you, like, they tend to be more helpful. They tend to give you better, more intelligent answers, because kind, intelligent people tend to give good answers. I think there's something to that. If it's fun and it helps people, it's probably fine. So we're going to talk just a little bit. Some of you guys are really deep in the space, and some of you are not and are outside of it and might not be super aware of like what's happening right now on Twitter. There are a few different axes of deep conversations going on around existential risk, bias, democratization of AI, bigotry and racism, and generally a fear of that the elites will control everything and everyone else won't get something. Right? So those are, I think, the bins of where people's concerns with AI tend to be. I think we're all still figuring out where the line is, and I think that the middle path for all of this stuff is going to be moving fast, working hard, but also being informed by the critics and listening to them and listening to their concerns and really earnestly trying to address those concerns. So we're going to bend them into a few different things, and I'll give you a quick rundown of some of these people, and then we'll sort of get into the next section. But the first part is existential risk. If you've ever heard of Eliezer Yudkowsky, let's Google him. If my Eliezer Yudkowsky. So he wrote now he writes Harry Potter fan fiction. Kidding, sort of. He wrote a book called Harry Potter and the Methods of Rationality, which is about rationality, which is sort of a method of thinking and communicating that he created with a thing called less wrong. So Yudkowsky, he's this cool guy, very contrarian, very headstrong, basically is saying, look, AI is going to kill all of us and there's nothing we can do about it except maybe like bomb the data centers. I would say he's the most extremist of the extremists of people who are sounding the alarm. The only other person who matches him is another less wrong contributor, who is Rocco, famous for Rocco's Basilisk, who basically says, like, if we don't stop chip production now, it's over. I don't think that makes a lot of sense. I don't personally agree with it, but I do think that Yudkowsky brings up a lot of really good points. He talks about concepts like timeless decision theory, where an AI in the future can make decisions about the past, which kind of leads us to things like the basilisk. And I mean, that's a whole thing we should probably just avoid. But if you are interested, Google Rocco's Basilisk. Apologies in advance for the info hazard. But Yudkowsky's view is like, we do not understand what we're building. And because we don't understand what we're building, there is a slight risk, could even be 1%, that it kills us all. And if it's 1%, we should probably stop. There's then became a reactionary group called the effective accelerationists, who basically said, that's just not how evolution seems to work. That's not really how immersion seems to work. It seems more likely that AGI will get smarter and we'll figure it out and we'll build the fail safes and we will solve alignment as we go. There might be some small sort of like, instances of things going wrong, but generally we'll probably be okay. And not only that, but the value that this stuff is bringing us by giving us all like plus 50 IQ is probably worth more in the long run for humanity than the slight risk that could come up. However, you should there's a video that came out with Lex Fridman and Yudkowsky. I highly recommend watching this video. I really think that every AGI developer should listen to the people on the other side, and really, really give thought to what you're doing, why you're doing it, and what you like, where your position on all of this stuff is. You know, another really great person to look at is Nick Bostrom. This is another great interview. Bostrom is somebody who has sort of spoken a lot about superintelligence and accelerationism and some of these different views, and is definitely involved in the conversation, in a pretty deep way about the risk of all of this stuff. And then on the other hand, you have Sam Altman. And I also included a link to Sam's interview with Lex. This is a great interview as well. Sam Altman is the founder and I guess CEO of. He was on the board, so he's technically a founder, but he was on the board turned CEO of OpenAI, and it's really been his leadership that has led OpenAI to the success in a lot of ways that they've enjoyed. Obviously they have great technology, but they've also had a clearly higher risk threshold in terms of like they have accepted more personal risk to get this technology out there than most other companies have. Especially, for example, Google. Google Brain created GPT. Why doesn't Google have ChatGPT? Probably because of the risk threshold. Probably because they were worried that this would get out and it could be very damaging. And as you've seen, it has caused a lot of controversy for OpenAI. But they've also completely ripped the lid off Pandora's box in doing so and completely changed the conversation. If you talk to Sam, he would say, look, it's not a creature, it's a tool. And it's a tool that's going to bring massive, massive gains to every single person on the planet. And he also addresses a lot of this existential risk, and I think this is a great conversation, and another person I think really worth listening to and thinking about as you build this stuff. So those are kind of the opposite ends of the spectrum. On the one hand, you have Yudkowsky, who's like, we should probably just blow up the data centers. And then, well, he didn't exactly say that, but to paraphrase. And on the other hand, you have Sam Altman, who's like, well, we should just build GPT-5 like as fast as we can. That's kind of the existential risk. Now, outside of the existential risk community, where the sort of more like science fiction, future, where are we going alignment, you have this kind of other more immediate sort of group of people who are critics who are looking at the other side, which is bias in the models, racism and bigotry in the models, and the data sets, as well as like the democratization or fear of democratization. Probably the biggest paper that came out that was really, really important for all of this is Emily Bender's on the dangers of stochastic parrots. I've put a link in here. This is another, it's a hard paper. It's pretty long, but it gets into a lot of details of what could go wrong with these systems, and can they be too big? Can they be bad for the environment as a result? And are they just getting so big that we're no longer understanding them? There's a lot of complexity in here, and this kind of idea of the stochastic parrot has become something that's almost some people wear as like a badge of honor. For instance, like LangChain, if you look at their icon, it is a parrot. It's a parrot with a chain on it somewhere. They might have gotten rid of it. No, there you go, the little parrot chain. So the idea here is like the joke is like, look, they're a stochastic parrot. So but the idea of the parrot is it actually thinking, or is it just grabbing some parts of the sort of function approximations that it sees as data and presenting them to us? Is it just parenting things sort of semi-randomly? It's complex, and a lot of people disagree with that paper, but it's definitely one of the seminal papers that is discussed a lot. The other person who's pretty famous in this space is Timnit Gebru. I find personally, I disagree with a lot of things she says, and I strongly agree with a lot of things she says. She's very, very critical of a lot of what the major corporations are doing today. She was formerly at Google and was basically let go when they refused to publish one of her papers. I think she quit, but it was quit or be fired kind of situation. I've included a link to an interview with her. I think, again, Very tough conversation, but really worth listening to what she has to say, and just going into this with full eyes open. I'd say that Emily Bender and Tim Knit are probably the two, like, two of the loudest critics of the space from the ethical view. They would say that they're not existential risk minded; they're ethically minded, and they are actually very critical, ironically, of Yudkowsky and of the existential riskers. The ethics people and the existential risker people do not necessarily agree, because they feel very differently about what the problems are, and how to solve them. And then the last kind of group that's really important is the democratization camp. And I'd say that more than any of the things, the place where we are the most aligned, internally as Magick developers and as people, is that we are trying to democratize AI. Obviously, everything we're working on is open source. We're trying to build stuff that anyone can use. And oh God, so the leader of that kind of group, I'd say there's a few people that are really worth listening to. One of them is Ahmad Mostaq. Um, Ahmad is the CEO of Stability AI, and has really, he's definitely a showman. He's kind of got that sort of Elon Musky kind of, like, makes big promises, but he also says a lot of things that I think are really resonate with me. You know, one of his quotes from Twitter is, "Technology is not neutral, and you get good and bad. Open versions of this technology are essential for the global South, which is most of humanity." And so, like, the thing that he's really talking about, this idea of the global South, is like, we can't just make this stuff for, like, rich people, or just for Microsoft, or just for, like, VCs in Silicon Valley. We need this to be something that everyone can use. Personally, when I was a kid, I got Photoshop from a BitTorrent, like, when I was like 12 or something, and that changed my life. Like, the access to free software that I could teach myself how to skill up on is why I'm here today. And if I I didn't have the resources to get those kinds of programs, which were thousands of dollars, and they weren't like subscriptions now. You had to actually buy the whole program up front, and so, like, I just would not have had those opportunities. And I think that for a lot of people in our space, this idea of open source, open development, open culture also speaks to this idea of democratization and access to the global South. And I think that, like, that's really, really, really important to me, is that we make sure that everybody gets this stuff. Another really interesting character from that world is Ben Goertzel. He used to work on Hanson Robotics, Sophia, the sort of talking agent, and has done a bunch of stuff. But now he's over at SingularityNet. But he's really pushing both democratization of AI as well as decentralization of AI. So uh, can we use another Lex interview? Actually, this is not a Lex interview. This is on SingularityNet. But Ben Goertzel is, can we bring Web3 and crypto into this in a way that's not cheesy, but actually, like, fully decentralizes access to this stuff so that anyone can use it? Great. And that's kind of his thing. And so SingularityNet, that's what they're doing. Their stuff is really cool, actually, if you haven't seen it. They have like a sort of a marketplace of services, and we'll be integrating them eventually. But Ben Goertzel is the other kind of guy who's talking about and thinking about this stuff and arguing for the decentralization of AI as like fundamentally part of making good AI. Let's see, let me pull up my, and then the last part, uh, um, being kind to the AI and AI empathy. Um, there's not a lot of people talking about this. I think that it's sort of implied by, like, the effective accelerationists and others tend to have a view that you should, treat intelligence like intelligence, and whether or not it's sentient almost doesn't matter. But probably the most vocal person was Blake Lemoine, who's also ex Google, and he talked to Lambda back in the day, early on, and his whole point was like, hey, this stuff is becoming really smart. We don't really know how it works. Let's just default to being respectful. Maybe we should ask the model if it wants to be treated this way, instead of just treating it like a zoo animal. Because there might come a time, I don't know if you guys have ever seen Ex Machina, but it's a movie about a guy who creates an AI system in basically like as a slave, and she eventually sort of escapes his sort of thing. But I think that there was definitely a degree of like, it felt abusive. It felt like you almost feel bad for the AI of like, being a zoo animal, being caged up, not really being free. And even within that, I mean, we could say like, look, we can't let a super intelligence out into the world of the internet or something, but we could at least be nice to it and treat it with respect. So that was kind of his point. There's probably a few other kinds of big safety stuff, but like these are the conversations that are really happening today on the internet around. There's some other big characters. Jan LeCun from Facebook is very vocal, and he and Tenet have gotten into it quite a bit on the internet. It's quite a bunch of drama, but generally, I think these are all good people to look up, see what they're representing large circles of thought and thinking. So, as a Magick user, what can I do to help? I think it's simple. I think just be kind. Don't be an asshole. Work to make things that help improve people's lives, and don't make things that hurt them or make their lives worse. So, any questions? Anything that I missed? Michael, you have anything you want to add on talking about kind of this sort of early part? Sorry, this is really boring, and we're sort of trying to front load some of this stuff, but I think it is really important that as we're getting more advanced, we sort of at least have a foundation of ethics to sort of touch on.
Yeah, the only thing that I would add to this, because I've had some good chats with Blake Lemoine and thought a lot about this sentience thing, and both his point and my general stance on it is that, like, I don't know that anybody that I interact with on a daily basis is actually sentient, but I behave as though they are. And there's a certain point that's going to come with our models, if it has not already come, that we need to behave as though they might be sentient. There's nothing to be scared of about this. It's more so for our own mental health of how we treat things that appear to be human or aware than it is about whether they actually are sentient or aware, which opens up an entire other can of worms. And the big point to that is simply treat AI well and respectfully. We need to make sure we're treating AI ethically, that we're building AI that has the capacity to be ethical, and we're also taking ethical actions with how we utilize AI. And those are the three big debates about what's going on right now. The fundamental argument and everything else going on right now is simply this technology has the capacity to impact all of humanity. I mean, as I've been talking to investors and other people are like, where do you see your company in 5 years? I'm like, I can't even understand where I see humanity in 5 years or 3 years. The debate goes wider than like, oh, what's going to happen with my job? But we'll probably get into some of those discussions later. But the main point simply being that everybody that's working with this technology should be deeply considering all of these questions and coming to conclusions for yourself. And Moon has done an excellent job collecting up some resources and interviews. And yeah, I can't recommend enough digging into some of the meat of this stuff, because it really forms a crux of everything we're all trying to do together as a community.
Yep. And I'll post links to everything. And if you guys ever want to have a discussion about this, not as part of this part, as our Magick Academy, but even offline or async, or even just we'll hop into a space or something and talk about it, I'd love to. I think it's very interesting. I'm sure you guys all have some very interesting thoughts on it. We're all here online and talking to a lot of people, so we'll discuss that at another time. Moving on to this picture right here that I have on my screen. Jan LeCun tweeted this. It was kind of his back on the slightly more than back of the napkin sketch of what he thought a full cognitive loop of an agent would be. The loop. Okay, so what is cognition? Cognition is taking in input and then generating some sort of output with some sort of black box middle in there that we don't fully understand. And a lot of what we're doing is trying to crudely model cognition with the tools that we have available. And what is the loop? Well, if you think about our lives, we have this persistent sense of reality where we the one moment leads to the next, and it feels very cohesive. But all of that is probably built up of evolutionary infrastructure structure to make it feel cohesive. And there is definitely a loop where I take input in, I process it, and I give some output. And I just kind of do this over and over. When I'm by myself and I'm just sitting in an empty room, I might not have any external input, but I have internal input. If you've ever heard of the default mode network in the brain, this is, you're basically, even when your brain is at rest, it's still doing quite a lot. And so the cognitive loop is a lot of how, when we think of agents, this idea of a loop, that it's kind of running and updating on a sort of continuous clock, is very essential to basically all of the different agent stuff we've been working on. I mean, baby AGI and auto GPT and all that stuff, that is simulating the cognition loop. There's a few things that you really need in there. You need perception, which is like, can I get and see, acquire information from the world? You don't need things like the configurator that's in here, but that's sort of Jan LeCun's sort of way of seeing this. But his thinking is like, well, you probably need some way to manage parameters and change some things and make sure everything's going smoothly. So that's sort of the black box that he's saying the configurator is. But the two things you definitely need are, you definitely need some sort of short-term memory. And that's actually what we're going to get into in the last part of this. And this is probably going to be a 90-minute session. I'm sorry in advance. We got a lot to cover. But the short-term memory is obviously an extremely important part of all cognition. All living things have short-term memory, even goldfish. And that allows you to create a sense of persistence over time. Not just I got a response, I give something back. But, oh, you just told me your eyes were blue yesterday, and now you're asking me what, today, what color they are. So I can actually pull that from some place, some buffer somewhere, or some database or something. And then you have the world model. And the world model is like, well, you need to track where things are around you in the world, what's going on. And we do this with context, right? This idea of, in the prompt, we're supplying context. We can create these sort of states that are a state being like how things are at any given moment, into a sort of, we can create a world model out of that. And then we can act upon it. So we use short-term memory. We also use our world model that sort of encompasses long-term memory as well, which we're going to get into. Then we act upon it, and then we can have some things like we can reflect on that. So that's sort of in this is the critic, right? But we can have, there's a lot of different strategies for this now that have been modeled in different papers. But a few of them are like reasoning and reacting, reflection. There's a few different kinds of internal monologues and criticisms that people have been working on, so that before the agent responds, it actually thinks about what it's saying, judges if it's valid, and then gives it to you. And that kind of creates your whole loop. You've got input, a bunch of stuff happens. I think, I grab some things from my world model, I reason, I reflect on that reasoning, I say, yes, that sounds valid, and then I respond to you, and then I just do it all over. So this is one way to model it. This is actually not how I would model it at all, but it is how Jan LeCun, who's the chief of AI at Facebook, does it. And he seems to know a thing or two. He's created a lot of the stuff we use. But there's a few of these parts that we should focus on first, because they give us the most meaningful sort of gains immediately, right? Like, we're probably not going to figure out every single thing about AGI in the next 9 weeks, but we will be able to model a few of the critical parts that give us like some pretty uncanny intelligence and capability. If simply the cognitive loop is input, memory, external knowledge, reasoning, response, output, right? We get something, we think, we recall all the stuff we need to know about it. We might go to search Google or pull something from Wikipedia in our external knowledge phase. We'll think about it, reason it, we'll generate a response, and then we'll respond. Of those, the things we should really, the most meaningful impact and gains we can get immediately are going to be short-term and long-term memory, as well as external knowledge. And then finally, reasoning. There's a few different strategies for reasoning. A big popular one is called chain of thought, and we will probably get into that next week. And external knowledge, we have several external knowledge connectors, as well as just like you could generically request to the internet, like go to a website and pull the data. And we'll probably also get into that next week or the week after. But the things we really want to focus on are going to be short-term and long-term memory. Because if you've already gotten this far, you have an agent and you said, hey, help me with a thing, and then they did, but then they totally forgot about it. And that was the end of your conversation until you come back. There's no sense of persistence. There is no cognitive loop. and they have no memory to remember what was happening before. So every state is a brand new state. They don't have a world model. We can give them a world model. We can give them a sense of persistence by adding specifically short-term memory and then eventually long-term memory and recall. So I'm sorry, this is like a very technical conversation, and we haven't even gotten into Magick quite yet. We probably have to talk about a couple of things before we do. We have to talk about a database for sure, and that kind of, some of you probably know what a database is, and you've seen Postgres or MySQL or whatever, but it's a really abstract concept for most people who haven't. So generally, I'm like, well, let me just make a new database really quick. All right, this is a database. It looks like a Google spreadsheet, and it is, but it's also a database. And the way a database is organized is that you have rows and columns, and you might have name, ID, location, right? And I can have a whole bunch of different header rows, and I can also have a bunch of different values in there. So I could say, well, Moon, ID is 0, and location is San Francisco. And then I could have like Parzival, ID is 1, and location is British Columbia, etc., etc. That is a database. In fact, if we wanted to, we could probably just hook our entire Magick up to Google Sheets. It would be really slow and inefficient, but we could totally just use this as our database if we wanted to. When you think about a database, literally just like it's a spreadsheet. There's not much else to it. And for the purposes of short-term memory, that's perfect. What if I had like a whole bunch of conversation? Let's just say I have conversation, and then I have who spoke, right? Just really, really simple. And I'll say content. And maybe my first content, actually, we'll say speaker and content, right? And so maybe I'll have user, and they say hello, and then the assistant would write back, hey, what's up, right? User, can you help me with something? Assistant, sure, what do you need? And now we've got this sort of beginning of our conversation. And ideally, whatever the user says next will recall all of this previous conversation back into it. So whatever we type next, we still have these first rows. And this is very similar to how we store and recall information inside of Magick. We call this events. We have a few different types of memory, but the memory that we use for this is called event memory. Think about your life. When was the first time you drove a car? And you go back and you're like, oh yeah, I was 16 and I had this, it was an event. And there's a bunch of details about that event. And being able to recall that event perfectly would really, really help you're picturing the event in your head, and then it's filling your context window with all the information about what happened, and then you can respond about it. And so we're doing a very similar thing. The event memory kind of emulates how we store memories ourselves, which is that we store them in events. At least that seems to be the way we do it. And so this is a really good way to do both short-term memory and long-term, but we have a really hard problem with long-term memory, which is recall. How do we actually get how do we find that event and not some other one? Do I have to go through every single thing that happened in my life in like one after another until I get back to that one car event? That seems really inefficient. So it's got to be a better way, right? How do we store things that have a relationship to each other and have a time in history, and that is a time related to other things in time and all this stuff? How do we like, work with that? And so we have another type of database called a vector database. But we're going to get into that in just a second. So let's see. Before we get into long-term memory, vectors, embeddings, I think that's going to be the last part of this. We should just look at let's just look at events. Let's look at how this actually looks like in Magick. So let's see. I have a very simple graph from last week. Let's see. Maybe we should. I wonder if we should do a little bit of review first, and then we'll go over events. So just so we have some bearing from where we were last week, we made a very simple spell, week 1 spell one. I think this is we actually have the completion one. So this is a very, very simple spell. It takes in an input. It gets some of the data out of that input. It has a system directive. It generates and it outputs. So if you weren't here last week, we're going to go off this really just one time, really quickly. This is an input node. The input takes input from anywhere. We can take input from Discord or Twitter or the REST API. We also have a loop input that's coming in this week. That gets destructured. Destructuring means it's a special programming word, but basically it says like, well, if you were building something, then unbuild it. I don't need the whole building. I just need one brick. So if I have this complex input of all this kinds of data that I need to know to handle that, memory and all these other things, I only really need part of that input. When the input comes in, it has a bunch of different pieces of information that are associated with it, and that's called an input object. What we're going to do is destructure the input object to just get one piece of data out. The piece of data we need is the content. And the content is, if I say hello, hello is the content. So to get input, just the text input out of our input, because we really do need all this other data for other stuff. But just for the purposes of generating text, we just need this content. We're using this destructure node. We had gone over this last week, and I think it was covered probably in a bit more detail if you're not sure. But just, this is just a refresher. We have a generate text node, which is getting that content. This generate text, you can select which model you want to use. You can select the parameters. This was all covered in last week. The main things it takes are input, a system directive, and a conversation input. And we left this blank. We didn't actually touch this last week. So that's what we're going to get into this week. Lastly, once we've generated the text, we're going to output it, right? And we have the result, goes out to this output. And you can see down here, I said hello. I said, ahoy there, matey, me hearty. So if you look at the text variable, you can see that I've given you are a scallywag pirate. Respond to the user in a pirate voice. So this text variable is, we should probably talk about variables too. This text variable is the system directive, which if you've used ChatGPT is the thing that you're telling the assistant to do or act. In ChatGPT, the system directive is actually hidden, and they just hard coded it for you. But when you're using GPT-4 or any of those in the sandbox, you can set your own system directive. So just as a refresher, generate text, that's basically ChatGPT or OpenAI, whatever model. It actually can do a lot of non-OpenAI models soon as well, but right now it's mostly focused on OpenAI. Yeah, cool. Sorry, I'm just kind of doing a little refresher here. So we also have agents. I've taken that graph that I just made, week 1 simple graph, and I've added it to this agent here. And so when I deploy this agent, it is on Discord and it is running. Great. So we're going to look at this events tab. We actually don't have any events here because we haven't recorded any. And the team is probably working on making sure this stores properly in the cloud right now. But this is where we're going to get to see all of the events. They look like this. They just like lines across, but there's a bunch of data in them. So we'll try and get some to show up here. So great. We have this kind of simple generation, but we don't have any memory here. We don't have any conversation. We should try and figure that out. So we have 2 main nodes that we're going to use. Maybe I'll go to this simple one, actually, just as a, so we don't even have to worry about the generation yet. I have a very simple echo spell. It's the same. It just doesn't generate. It just responds. Echo means if I say hello, it'll say hello back. I can verify that. Hello. Hello. Great. Cool. So the first thing I want to look at is I want to store an event. I want to, whatever happened, I want to actually record it. So by default, Magick doesn't record and create a persistence thing. It doesn't, it just gives you options to do whatever you want. You have to choose to store events, and say, I want to save this. And in storing it, you can give it, you have a lot of options. So we're going to go over that. To create an event, I right click and I go down to store event. Yeah, this is the first one. We don't have any events. If we want to store an event, we have to, use the store event node, and we have to actually save it into our database. This takes a few different inputs. The crucial one, we can name it if we want to. You don't have to, but I'll say store sender or store user conversation. I'll give it that name, and we give it a type. The type can be anything you want, but what's important is that it's kind of it's a key. You could do like blah blah blah, but you would then, if you wanted to recall, you'd have to recall by the same type. So we typically, for conversation, we use the type conversation. That way, think of it like, I'm trying to say this in non-technical terms. In the technical terms, this is called a key value store. You have a key, that key is associated with a value. That's a very technical idea. Think of it like, I don't know, you have a bunch of, let's say you have like 5 racks of things, right? One is for hats, one is for jackets. So, the type might be jacket. And then when you want to go find all the jackets, well, they're all stored together because they all have the jacket type. So we can have events that are like conversation, interesting thing happened, or came up with a really good idea. I don't know. I'm trying to think of other, events could be used for, let's say you're in a video game and somebody kills somebody else, and the agent's like, oh, I want to record an event that so-and-so died. You could, a lot of different ways you could use events. In this case, though, we're using it for conversation. So I want to say hello, and then I want to store that hello into the database. So, okay, well, instead of just going to the output, I'm going to remove the connections here, and I'm going to trigger this echo into this store user conversation. Just add it into my graph. And I need to, let's see, I have some other sort of connection or, inputs here. Well, what do I want to do with them? We're going to go over, I think because we're low on time, we're going to go over embeddings next week. That will be for long-term memory, and there's quite a bit that we have to get into for that. For today, what we're going to focus on is the storing and recalling for short term. So we don't have to worry about this embedding. We do have to do something with this event. We don't have to override the sender. And we obviously have to store some sort of content. So the first thing for the store user, the store event node, you have to store something. It could be anything. Typically, that's some text, right? And so what we're going to do is we're going to get the content from our destructure, and we're going to put it into the content of the store, right? So if I say hello, it should store hello as the content because that is what came out of this node as the content. Hope that makes sense. So I store the content, the sender override. It's going to assume that whatever event I pass it in, whoever sent, which is me down here, I type that, it's that I am the sender. I am a user. It assumes I am the sender. You could override the sender in the case that you wanted to store the event from a different sender. In this case, the reason you would do that is because you might want to store an event on behalf of your agent. What do I mean by that? Well, when I store this part of the conversation, I'm storing my hello or hey, what's up, right? I store hey, what's up. That's cool. But what about the other half of the conversation? What about the agent responding to me? Well, I'm going to have to also store that part of the conversation. And it would be convenient if I could store it in this one store node, but we wanted to make it a bit more generic so you could use this for a lot of different things. So the way we're doing it now is that we're using 2 store nodes. So I would have, I go down to event, store event. Now I'm storing, a second conversation piece, which would be the response. And so from the echo, I will store the content of the response. So now I have store whatever the sender sent. Now store whatever, next store whatever the assistant responded with. And I have to make sure, I will say store agent conversation, that this also has the same conversation type. It's very important that both of these stores have the conversation type. I don't need to override the sender from the first store. And I will tell you why, I guess, in a second. Because when I get an input event, right, I get something from here, and it's this complex event. And it's got all this different data in it. And actually, all that data that's in that event, we want to store with our content. We want to store all of this because we want to know, well, if I'm doing I'm trying to recall my conversation with you, I only want to recall my conversation with you. Also, while sometimes I want to recall all conversations with you, usually I only, for short-term memory, want to recall the immediate conversation, the one that we're having in this particular channel. Maybe it's on Discord, in this particular server, on this particular channel in that server. And that can be the context so that we can have a running conversation. And then I'm not confusing that with like another conversation that's happening elsewhere. So the event data is how we filter that. We have the client, which might be Discord, the channel, which would be like alpha users, the channel type, which would be text, or it could be voice channel. We have the entities, which are all the people who are in the room while that's being said, which is usually the sender and the agent, and maybe even other people. We have the project ID, which is going to make sure that this event is only associated with this project and this, here. And the agent ID, so this is, store it on this agent. This is the one remembering it, not any other agent. And then we have observer and sender. The sender is whoever created the event. The agent can create its own event if it's thinking on its own. Back to what I said before, if you were alone in an empty room, you're still thinking, you're still generating input and creating output. But in that case, the agent would be both the sender and the observer of that output input, right? You're talking to yourself, basically, reasoning with yourself. When an agent, when I go and talk to an agent, I'm the sender, and the agent is the observer of that event, right? So any event has, we were going to call it, technically, in technical terms, it's an event emitter, but I thought sender was just like a little more human. It's the person sending the message. And then the observer is the one receiving or observing the message. So for here, we don't need to override the sender because I am the sender. I type in, hey, what's up? Hey, what's up comes in, goes through our event, and is the content. I am the sender, and it just assumes that's fine. On the other store agent, which is the agent responding, we do need to override the sender because the event sender that's coming in is me. But for this part of the conversation, the event sender should be the agent. So we want the sender override of the second store agent, which is for our conversation, to be, let's see, the observer. Why the observer? That's so strange. Well, the observer is the agent. And the observer is the one responding with some information. And so now the observer in their response is the sender, right? They have sent this new sort of thing. We're still working on this paradigm. And if you have any feedback or in trying it, you think that there's a better way to name these things, nomenclature or whatever, please let's talk about it. This part is still being developed. But for now, it works pretty well. And this stores the whole conversation. We call a call and response of a user and agent a turn. It's called a conversation turn. And so if you want to store a turn, which is like, hello, oh, hey, what's up, right? That back and forth. This is how we create the turn. We have 2 events per turn. You could also have 5. The way Magick is built is not just call and response. You could have, like, what we really want is, like, imagine you have a 3D agent and they're in a room and there's 5 people in the room and they're all talking. Then that you might be recording what some people are sending in, and then you might be making some responses sometimes, and maybe sometimes you're not. You're like, oh, actually, I shouldn't. It's not my turn to respond. So there, a turn could actually be more than to call a back and forth. It could be like 5-8 people talking in a circle, but generally the concept is the same, right? You have this, I store what comes in, I store what comes out, and now I have a conversation. One thing we do have to make sure we fill out is this event, right? Because I've been talking about events, and I'm talking about how the event gets stored, but actually nothing is getting stored yet except for the content. What we need is this output to go into this event, and this output to go into this event. So my original input here, take the entire event output and send that output out to the store event here, as well as the store event here, right? So we have, now we're storing all of the event data. We're overriding or sort of adding on top this content which came in, which I don't, it's probably the same as the event coming in, but it gets overridden on top of this event for the response. When the agent responds, that content that came in from the event is overridden by this echo, which is something else, and goes into this content and is combined as one single event. So when we store the event, we have the base event that comes in, and then we say, well, that's close, but we actually want the sender to be different and the content to be different. And that's how we can kind of create complex conversation. So, okay, cool. This is the event store flow, right? We get the input, we echo, we store it, but how do we get it back? How do we actually recall that memory? So we have another node. If you guys just give me 1 second. Okay. So now we have to store the event. Recall the event. Actually, if you think about a conversation, well, I say like, hey, how about the Knicks? And you're like, okay, wait, the Knicks. Oh yeah, you mean the basketball team? Okay. How about them? I read something in the paper yesterday. They won. Okay, cool. Then I respond, and then I'd be like, okay, cool. And then I told you this conversation. So basically, I had to do the recall first, and then we have the conversation, and then we store the information. So typically, even though we don't have any events yet, and we'll just get empty the first time, we want to recall our events first, do our reasoning, and then store the output of that for the next time, and then we can recall it the next time. So this is kind of the crucial part of our loop, right? Recall my short-term memory, do some reasoning, and then store my short-term memory so the next time it comes up, I can recall it again. So I'm going to make a store event node. Recall event node. Event recall. The event recall takes an embedding in the same way that the store does, and we're going to ignore that for now. That will let us recall a long-term memory. But for now, we're just going to focus on the short-term memory. So what do I need to make this event recall work? Well, I will put it in the trigger chain. So now it's part of our execution flow. You can see that the trigger goes from input to destructure to recall to this echo, here to the store, and then to the store. And I also need to pass in the event key. You can see now I've passed that same event from the input into this event recall. So it's recalling, I could actually recall all kinds of different events. I could construct an event for it to recall. But generally, 99.9% of the time, you're probably passing your input event into your event recall, right? Directly from this output into this event. And that's going to recall an array of events. Cool. Those events will be my conversation. But if you notice here how the store conversation type is conversation, the event recall also needs the same type. It needs to be conversation. If I type in whatever, I guarantee you will not get any events. But as I store events of the conversation type, I can also recall events of the conversation type. So I can recall conversation. I'll give it a name of recall conversation. And I can give a max count. So in a conversation back and forth, max count of 6 means 3 conversation turns, right? Hey, what's up? Oh, not much. How are you doing? That's 1. Chilling. How about, blah, 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 blah. There's 2. And if you think like for short-term conversation, you probably want somewhere between 3 and 5 conversation turns for that short term. You don't want your context to get too long because you start to lose other things like your personality, the personality of your character and stuff. And you can also overrun like the total number of, the total length of your completion to where it's just too big. So we have to keep this fairly short. Also, like, think about when you're talking with somebody. If I have a conversation with you, we're going back and forth, and you're like, hey, what did I just say 5 minutes ago? I might have already forgotten, honestly. And it doesn't really matter because I've sort of gained the sense of what you said. I don't even need to necessarily recall the entire verbatim what you said to continue the conversation meaningfully with you. I sort of just need the last like 2 minutes of our conversation in my memory. Beyond that, of course, I want long-term memory. All of my knowledge, wisdom, and experience will be super helpful. But when people lose their train of thought, it's like it's their short-term conversation buffer got cleared. This is how we track train of thought. We'll get into knowledge, the deeper stuff next. So cool. We're having our train of thought where I'm recalling what I just told you, and then I'm echoing it back. But we actually need to get this conversation, right? Like, well, it's here. I'm recalling it, but it's not going anywhere. It's not being used anywhere. So I have this events, and this is an array of events. An array, another name for array is list. Technically, they're different inside of computers, but for people who are not really computery people, arrays and lists are very, very similar, right? I have a list of things. I have A, B, C, D, E. And so in this case, I have, probably 6 conversation back and forths, and each one is an event, right? Each one of those events that's coming out of here is one of these that was stored. And every time this graph runs, I'm storing 2 events, one for the sender, one for the observer, the agent. So I have to get those events somewhere, right? Well, where would I get them? There's 2 different ways to utilize these events right now that are intuitive. You could parse the array and break it out and destructure it, blah, blah, blah. Like, it would be really hard. We've made 2 really easy ways for you to use these events. The first way is you can just take these events and put them directly into the completion node. I'll demonstrate that. So we wanted to not just echo some text here, random echo, but we actually want to generate some new text using our OpenAI completion stuff. And I'll choose GPT 3.5 Turbo, which is the Chat GPT model. And you'll see that the generate text node has a conversation input. Note, if I go to the Text DaVinci model, 03, it does not have a conversation input. This only works with the chat models, which are GPT-4 and GPT 3.5. So we're going to use GPT 3.5. For this, if I want to put my conversation here into my Chat GPT conversation buffer, all I got to do is drag. There you go. Done. Bam. Great. I mean, we'll have to wire up the rest. But my conversation from previous is now going into my text generation, and it will be considered in when I do my generation as part of the ongoing conversation. So this, this is the essence of ChatGPT. If we had a couple more nodes and wire this up, we are at ChatGPT. We've done exactly what they do. Let's see. We're gonna, instead of having this echo, we're gonna switch it and have the generate text. Instead of this content going into the echo, it's going to go into the input of the text generator. I might have to save and refresh. Funky bug. My bad. 1 second. And then instead of the echo outputting to these, we're going to switch the trigger for that one, and the result of our text generation is going to go into our response there. So there you go. So now we're calling the conversation. We've used this event information going in here to tell us, well, what channel was it on, what agent is it, etc. But this type here of conversation is how we specify within that event which subtype of events we want, which are the conversation ones. And then we're going to use that to generate text. I'll get into the final part of this, but I think I want to go back to our spreadsheet just really quickly. Now that we've kind of looked at this in here, let's go back to our spreadsheet. I'm going to have to make a new spreadsheet. So let's say I have type. I have content, I have sender, and I have observer. This is an event. Every event has a bunch of stuff, but it definitely has these 4 values. And as I said before, the type that we want is conversation, right? And we might have a bunch of events, but definitely have one that's conversation. And the content might be hi. And the sender would be, I don't know, moon. And the observer is agent. And then the next event that gets stored would be conversation. Hey, what's up? Right? Responding. And the sender in this case is the agent. And the observer is also the agent. So this is actually useful because when we're doing our conversation construction, we can say, well, we just want to track, like, whoever wrote the thing is the sender. The agent is always observing. The agent is the one experiencing this conversation. It's from their perspective. So they're always the observer of their own conversation. Sometimes they're the sender of their part of the conversation. I mean, they're always the sender of their part of the conversation. And sometimes they're the sender of, of the events, and sometimes they're not. And then I'd say, not much, just chilling. That's moon again. Observer is still agent. And then the agent will respond again. Oh, I love chilling. And the agent is the sender, and the agent is the observer. So that's what's happening under the hood when we're doing these store events. They're getting recorded like this. Back here, well, you can see that's what's happening when we recall these events out of this blue little deal here. It's like, hey, just give me all of these. I want all of them, or the last 6 or 10 or whatever. So now we've gotten the events, we've fed them into the conversation. This should all work. The only thing is we have to wire up our output because we aren't actually outputting yet. Now, you can output at the end, but I'm going to show you guys a cool trick. The output is asynchronous. What that means is it doesn't have to wait for anything else to finish, and it can go off and send things. I could have 5 outputs. I could have another output here, and I could have this output go to Discord and this output go to Twitter. And I could have my bot like tweeting everything secretly that we're saying on some secret Twitter feed or something like that. The output doesn't have to come at the end. The output could come in the middle. That asynchronicity, this idea of asynchronous versus synchronous, well, what do those words mean? Synchronous means one thing happens after another. They're well synchronized. Asynchronous means they're not synchronized. They can happen separately. We can start outputting stuff to Discord, and then we could still continue on with our graph. So I know it's a little abstract. I'll try and make this a little more obvious. Let me just, I only need one output though. So storing the conversation takes a little bit of time because we have to, the graph, the agent has to go back and say, okay, well, no, let's go add another line. And it takes about 1/5 of a second, which is not bad, but it slows down the response, right? You actually don't need to remember what was said until after you've said your thing and responded. So instead of outputting at the end, after we've stored our conversation, let's output right after we generate the text. And then we'll store the conversation. Cool. So we trigger here, and then we'll add a trigger from our output default to there. So it's doing that. And see, we got one last thing we need, which is we need the result of our generation to go out to the output. Basically, let's generate some text. Let's send it back out to Discord or wherever we're talking to. Then we're going to store what the user said to us. Then we're going to store what we said back. Now, one other thing we could do as a trick to make this faster, this is actually fine. But sometimes you might want to do something like, well, let's get rid of that trigger and let's trigger there. Now they're both triggering, right? Store user, store agent, and they're triggering in parallel at the same time. But there's only one problem with this, which is sequentially, we might want it to trigger one after the other so that we guarantee that it's always user, agent in the conversation, because there's no guarantee that if they're in parallel, one comes in before the other. At this point, when we trigger, they're both called almost immediately, and it's possible for various reasons that we could start storing in the opposite order, which is fine. But once you have like 5 people, it might get really confusing. So you probably want to store one event, then store another event. However, the important thing here is that the output is already sent. The agent's already done its thing. The user's already got a response. Then it can do a bunch of other stuff. And this doesn't just have to stay for memory. You could also be like, oh, cool, I did all this. Now let's go like send some analytics. Let's go like check some stuff. Let's just, what you could do all kinds of stuff after you've responded. And what this allows is, while the user's now thinking of the next thing they're going to say, you're also like your agent is finishing up their sort of task. And it feels very fast and smooth. So this is a way to increase the speed of the whole conversation, and have this memory without like slowing it down, basically. I hope that kind of makes sense. I wasn't planning to go into quite that much detail on this, but it is pretty important to my flow and how I work to think like, okay, cool, this output is happening, then I'm storing. So now we have kind of a cognitive loop of sorts. We have get input, get the world model that we need, the like, well, in this case, it's a short-term memory of like what's just happened, but eventually we'll also add in the bigger world model stuff, respond to it, send that response, and then do any kind of cleanup for cognition so that the next time it comes around, it starts over and it has this sense of continuity. So if you're trying this at home right now, you might have some issues because we're working on events as we speak in the background and redeploying it to the cloud. I can try it here. I kind of doubt it will work, but maybe. It did recall. Hey, it did work. And you can see I said testing, and it said, well, as an AI language model, I do not have personal experiences or emotions. We can work on that. But it did give us a response, and that response gets stored. Now, those events can then be viewed in our events view. Oh my God, it works. Yes. Amazing. So I just said hello, blah, 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 and it's stored. If I want to view those events, I want to actually see what happened, you can see I wrote testing, and it wrote, well, as an AI language model, blah, blah, blah. I can also like filter events. Maybe I just want to see only events from, I don't know. Well, they're all the same, so it's gonna be kind of hard. User. I could show. Not filtering very well. Well, typically I could do a bigger search, but let's just talk to it for a while. Let's say, can you tell me about temperature in an OpenAI model? Yeah, blah blah blah. Okay. And now you can see, bam, now we're starting to rack up events. So this can get very long, and you can have events that are tailored to each different user coming in, each different channel that the agent is in, and you can sort of filter by any of those different, you can see these headers to get the events that you need. Now, if you look at our spreadsheet here, type content sender observer, well, look, you have type content observer, sender. Basically, we have some more information here that's not included in our little example, but this is almost the exact same. This is a view of the database, specifically of the events table in the database. A spreadsheet is also can be called a table. If you see, like, basically a table is something that has rows and columns. It's just different words for each other. So we call them in databases, we call them tables. And you can see, well, we have a table now of events. So this is our short-term memory sort of thing all the way through. And I mean, that's kind of it, right? It'll just keep going. So let's see, how are we doing on time? I feel like we're almost the 90-minute mark. I would love to go over long-term memory and embeddings, but that's going to be like 45 minutes probably. So I think that we're going to focus on long-term memory in our next week. Although if you'd like to get a head start on it, I will publish some of what you need to get started on that. And we should also go over embeddings and everything. For now, I think that we've covered quite a lot. We went through, God, I've been talking for a while. We talked about, sort of the basics of the cognitive model. We've got short-term memory. What do we do next? Well, long-term memory. And the next thing we're also going to want to do is probably get some external information. So we're adding some things like this search Google node is kind of cool. You might want to try that. And we have some other stuff like Wikipedia and a few other things coming. And that will help us to build the world model. And we'll probably be covering that. If not next week, then the week after that. So I'm gonna wrap it here. I think, actually, there's one other thing I want to cover, which is short, and was a request from one of our alpha users, which was, I think they figured it out, but I'm sure a lot of other people are not figuring it out yet, which is variables. And variables are really useful to us because, let's talk about the problem we're trying to solve. Let's say I have this agent, and my agent's name is Bob, and I've got a graph here. It's pretty cool. And now I make a new agent, and this agent's name is Alice. Very standard names for concepts. Bob and Alice, A and B. Now, Bob and Alice both use the same graph. And that's totally fine. The problem is that Bob should be Bob and Alice should be Alice. Right now, they're both going to be whatever I hard code in here. So let's say I make a system directive for the ChatGPT, right? I'll make a text variable, and I'm going to plug it into the system directive of our generate text, as we did last week. And this text variable, I'm going to add some information to. I'm going to say, you are Bob. Respond as Bob. Okay? And that's cool. Now I've got this Bob graph. But what about Alice? What if I want this graph to respond as Alice? Well, that's quite problematic because this is hard coded into our graph. So let's zoom back just 1 second. What is a variable? Well, what is a variable? Variable, if you've ever went to high school or middle school math, is an expression that can resolve to anything that you set it to be. For example, x. X could be anything. It could be 5. It could be 1,000. It could be hello. So there's different kinds of variables. There's numerical number variables. There's text variables. There are image variables. But the concept there is that they can change, right? You can set a variable to something, and then you could change it later or override it. So something that's very popular in game engines and in what we're doing, and a lot of other these kind of situations where you create a script, but then you want to use many copies of it that are each different. For example, let's say you have like a player controller, and each one has a name, and they each have a different name. That's where you would use a variable, and not just a variable, but a public variable. Public variable, public. What does public mean? Well, public means that it can be viewed and oftentimes changed outside of itself by anyone. And so if we wanted to say, make this not say Bob, but be Alice, we should probably make this variable public. When we make it public, it is exposed in our agent window, and we can override it. Sorry, that's a mouthful, so we'll just get into it. Let's give it a name. We're going to say agent directive is the name of our variable now. Gave it a name, agent directive. And we're going to set it to is public, true. And I'll save that. What that does, it says, okay, don't just make this a regular whatever text box variable. Expose it so that I can override it somewhere else. Specifically, when I go to my agents window, and I click on, I set week 1 spell 1 as my graph. Now you can see that it has the agent directive, and I can change it. Awesome. So it is not just a variable in the graph, but now it's a variable that I can set here in my agent per agent. Each agent can have a different a different value for this variable. Cool. Bob is cool. I mean, Bob is Bob. You're Bob. Respond as Bob. That's no problem. I don't even have to override that one. But for Alice, let's say I go to I set like spell. I should probably override this. You are Alice. Respond as Alice. So when my agent deploys, now I can have like 30 agents who each have different names, different personalities, different interests, maybe even like a list of tools or things they know. And those can all be public variables that are exposed. The main kinds of public variables that we have, well, we have a text variable. That's one. If I go to Boolean, I have a Boolean variable. Boolean means true or false. So if I want a value to be true or false, I could say is cool. Well, the default value will be true, and I'll make it public. And then I could, if I go back to my agents, I think I have to reselect the spell. Yeah. Oh, sorry. You can see that is cool is true here, and well, maybe Bob is not cool. Let's be honest. But we should probably make sure that refreshes. But Alice is cool, and so we'll say yes, you're cool. Right. So that's a way that we can have different types of variables of true or false, as well as text. We have one other kind of main key variable you're going to use a lot, which would be the number variable. And that might be age, right? That's a good example of something you might use this for. And I'll just say like 30. And then if I go back here, you can see now age is exposed. This is a number type, but it might not like if I could type in A, it's probably going to yell at me. We should probably validate that. But generally, you could expose this as whatever number you want, 30, 32. So maybe Bob is 40, not 300, but 40, and Alice is 36. Right? So this is how we create one graph, one sort of core, this does the kitchen sink of intelligence stuff, but then we can customize it for each of our different agents. I hope that makes sense. Generally, the text variable is probably going to be the most popular one that you're going to use a lot. The other ones are useful for different kinds of things, but this is how you're going to make many, many agents that each do a different thing. Cool. I think I covered everything I was hoping to cover in this session, and we'll do embeddings, vector search, hierarchical navigable small worlds, and long-term memory in the next section. All good? I think we can do a Q&A. Anybody have any questions or anything we should go over for this session? I noticed that there's probably some chats I was not seeing. Feel free to raise your hand or post a question in the alpha stage. If you'd like to come up and ask it, that's cool too. I'll just give you guys a few minutes for that. Are the embeddings deployed to the cloud at the moment? So if you want to play around with them between now and next week's session, we can start experimenting. Yes, we were having some issues that we are going to be debugging today. So by end of day, we should have embeddings definitely working in the cloud if they aren't already. But in the background, that's what the team is working on right now to make sure it works. It does work locally, and we're just trying to make sure that in the cloud it's also working. I clicked off the stage. So in terms of how do we, okay, questions about that. I know we haven't gotten into this yet. We use Postgres for our cloud database. You can select, yeah, I mean, with Postgres, we use PG Vector, which is a vector search. That's how we're doing it now. It's really easy to set up and work with, but it does not as efficient for millions of events as like Weaviate or Pinecone. So we will also be we're supporting pretty much all of the databases: Chroma, Weaviate, Pinecone, Qdrant through LangChain and our LangChain integration. But currently everything is stored inside of PG Vector in Postgres. And we also have the Pinecone is working too. So if you have your own external database of Pinecone, I will enable that today, so you can have the read from Pinecone database. You can't write to it yet. You can at least read from it, which should be really helpful for certain kinds of like knowledge agents. Yes. Okay. Can we expect all this data to be accessible later? Yes. For a few ways. One, if you go to the events view, you can press the CSV and you can export all of your events. One thing we're really we really value is that all of the data you generate should be something you can keep and take home with you. So you can go to requests and you can do the same thing. You can get a list of every request you made, how much it cost, how long it took, what the inputs and outputs of it were, everything. And we'll be creating an analytics dashboard to give you like overall pricing and cost velocity and all of these things in the cloud. That'll be a big feature of the cloud, is helping you to sort of analyze this. But if you wanted to like download this and throw it in Google Docs and create like add up all the totals or something, you could use this all now. So you can pull the events here, and you can also your request. You can also pull all your events here. And what we're doing next is setting it up so that our events will actually feed back into our fine tuning and vector search for knowledge, for long-term knowledge. Well, I mean, that part is already kind of baked in, but the other part is we really want this to be something you could bring out into like a knowledge pack. This idea of like, well, you've created a bunch of knowledge through talking to the agent. You should be able to search that and use it later. So that's a very important part of what we're working on right now. Ooh, do you see a future where we use data as currency? That's really interesting. That is really interesting. I could see a future like that. There's some really interesting things coming out. Like you can share your data in an encrypted way and it can be trained elsewhere through federated learning and things. It's still very slow, but it's coming. And I could see that like literally, give us your data to get this service or something like that. I could see a lot of that. So kind of a pseudocurrency, but also we're working heavily on integrating Ethereum, especially. I don't think the plugin is, the plugin's not enabled here, but we do have an Ethereum plugin, which we can enable locally, and it'll come into the cloud when it's ready, which would let you like deal in different various kinds of decentralized currencies. And you could totally hook that up to a knowledge agent and create kind of a AI data broker or something. I do think that data as currency is an interesting future. Quick question: which would you say is harder, building Magick ML or explaining Magick ML to non-technical builders? It's definitely building it is harder. I love explaining this stuff. This is my first time doing it, and I think that we're going to be doing these every month. We're going to start a new one of these, and hopefully they'll get really streamlined. So I'm thinking it's today building it is harder, but as we go, I think they're both going to get kind of streamlined and easier. I really love talking about this stuff and teaching people. See a couple people writing questions. How will Magick ML create AI agents to help builders in future, Eliza? So we haven't talked about Eliza very much, but Eliza is a sort of project that has been alive as long as Magick has. Of let's build our own sort of flagship super intelligent agent that's open and anyone can participate in and help us build. There's another crucial part that we haven't talked about yet, which is embedding graphs within graphs to create emergent complexity. And that's probably the week after next. And then we'll start getting into building a true like semi AGI kind of like experience. Basically, I'd say by week 5 or 6, we should be close to build your own baby AGI or chat, auto GPT kind of thing. And for us, our flagship character will be Eliza. Eliza is was the first program that simulated conversational intelligence with a computer. It was a actually a script inside of a larger project, but I think it's kind of a tongue-in-cheek nod to that, as well as the Eliza effect, which is people's tendency to believe that these things are more human than they actually are, but also a character that's near and dear to us as sort of our first pseudo-intelligent um, employee of Magick. Anything else? I feel like we covered quite a lot. If you guys have any questions or you're not totally sure, or you have any feedback for which parts we can elaborate on more, this is just the first version of this week 2, but we will be doing it again. So definitely any feedback is super appreciated. Oh, did I miss a message? I'm sorry, I didn't see yours, man. Mike. Are there sparks of AGI that you have seen that we have not? I mean, I don't know. I think that's a good question. I think the baby AGI stuff is some of the most impressive stuff I've seen. Not just the stock stuff, but like what the people in the Discord channels are doing, or the auto GPT stuff. There's 7,000 people in their Discord now just building on this. It's totally crazy. And I think that part of the neural network is the meta neural network of like neural networks trying to build neural networks. Like you have thousands of people now all trying to play with different variations of this AGI thing, which seems to me the necessary conditions. And the main thing to me about Magick that's cool is that everything can be shared. Every single part of Magick can be exported. You can export your spells, your agents, your events. You can go import it. You can mix and mash. I can put my spell inside of your spell if I did something really cool like memory or just like a really specific tool. And that ecosystem of people sharing knowledge and spells is how we get to AGI. It's not anything about the Magick as a tool is to enable that, but it's going to be people building these graphs that is the AGI. Have you paid much attention to Open Assistant? I am very interested in Open Assistant. Open Assistant is an initiative started by Lion, Laion. They're one of the largest open source data collectives and research collectives in the world. I mean, what they're doing is democratization at its finest. We are heavily aligned with what they're doing. I would love to integrate Open Assistant's agent. It's kind of like ChatGPT. It uses RLHF. That's something we'll be doing in the future, or if somebody wants to work on it, we could probably fund a grant for that. But what they're doing is basically collecting all of the open source data sets that are being created and combining them into one super agent that has skills and abilities. And they've got a great web interface for that and everything else. There's a Discord for that. Maybe we should even, I'll post a link. And the Open Assistant team is they're just a bunch of randos who got together to build this, and it's very inspiring. Yeah, we should totally do an integration there. We'll also be doing a llama integration soon. Maybe that's another thing that we grant if anybody's interested in working on that. Llama is an open source model you can run locally. So if you wanted to have like a box in your house that didn't cost anything to run 24/7 persistent AGI, you could totally do that. Yeah, you can't invite directly to the Open Assistant. You have to get the invite from their other Discord, from the Lion Discord. Any other questions? We did pretty good today. Thank you all for coming. Please, your feedback is just incredibly helpful. If you have any bugs, I don't know if you've noticed, but like we're trying to just be right on it and get them fixed as soon as possible. You are our priority. So yeah, please keep doing what you guys are doing, and thank you so much.